Um, so hi everyone, I'm Leo again. If you were there on the first day, you would know that I'm one of the teachers. And today we're going to guide you through today's lecture, which is Intro to Botmaking. I am here with one of the other teachers.
Yeah, so my name is David. I'll also be assisting Leo in this lecture about bot making.
Okay, sounds great. So if you all are ready, we're gonna start. You can see on my screen that I've shared the packages already defined, the preliminary packages for this code. You might need to add more packages if you need to from the Java package or from the Battlecode package itself, which is right here. So your class name has to be robot player. It's defined as a public class. And in our game, we're going to count the number of turns that we've played using the variable turn count. And then RNG is the random number generator, which generates a random number. You'll see the purpose of it throughout the tutorial. And then we also have defined the directions constant, which has all the possible directions using the standard cardinal directions like north, south, west, and stuff. So yeah. Oh, okay. Okay. I hope it's better now. So yeah, we're gonna implement the function run and run tower. You're going to see what's the use of these functions as I proceed with today's lecture. Run is a function that takes in the robot controller RC as input, and the robot controller, you can basically see it as a way to control your robot. So it gives you access to like a bunch of functions that you will be able to manipulate the various entities in the game. So we're going to start with a while loop inside because the game is basically a repetition up to someone wins or someone loses. So we start with an infinite while loop. Okay, it's not really infinite because once someone wins, it will basically stop. Yeah. So every iteration of the while loop represents one step of the game. So we're going to add the count here by 1. And then the logic that we're going to follow here is that based on the type of the robot controller, we're going to determine what is the robot, what is the type of the robot. Like we introduced on the first day, there is the soldier, there is the mopper, there is the slasher, there's a tower, and all of these things. So I'm going to check which one is which using a try block. RC.getTime gives you the type of the robot controller. In the case of the soldier, we're going to run the function run soldier. We've not yet implemented a function, but it will be done by the other TDF I talked about at the beginning. The case of the mopper, we're going to run the function run mopper and pass the robot controller as parameter. In the case of the splasher, again, we're going to run the function run splasher. And pass the robot controller. And then if none of these conditions are true, we are going to go to the default and run the tower function. Here it's showing this red underline because I've not defined the catch block. So I'm gonna do that. Like you could see in the function definition, the function is supposed to throw a game action exception, which is a special type of exception that has been created by the T-devs to indicate when you are trying to do something that is illegal in the game. So that's the game action exception. So in here, you can choose whatever behavior you want your code to do when you try to do something that's illegal. So right now, I'm just going to do a basic print just to say that game action exception. But you can basically do whatever you want here. Print stat trace, I guess you know what it's used for. It's basically just prints trace of function calls which led to the exception. That's like a stack trace. We're also going to catch a generic exception. In that case, we know for sure that the exception is not because you're trying to do something illegal. So once again, you can handle it however you want to handle it. Here, I'm again just going to do a basic print. So we define the finally block. Here is something that will execute basically every time that the try block is executed. And we're going to run this function. So that's basically it for this function. So here's the general function of like the backbone of the game. We're going to, for every iteration that is executed, we're going to continue counting the number of turns and then check and then change the behavior of the code based on the nature of the robot controller. So I'm just going to implement the run tower and then the other TDF is going to do the other behaviors. So like we said on the first day, the tower is basically a game element that allows you to generate more money or like generate more players or yeah. So for the run tower, it also throws a game action exception, which like I said, will only be thrown if you try to do something that's illegal in the game. So we're going to start by trying to, this is now implementing the strategy of the game. What I want my player to do right now is that if you can upgrade the tower, you should upgrade it. So to do that, I'll call this function robot controller dot can upgrade tower. So if it's possible to upgrade the tower, now we know that the robot controller is a tower, or like the type of the robot controller is a tower. So we're going to get the location of that tower, which is the robot controller, and check if we can update it. If we can, we do update it. So upgrade tower. Yeah. And now what I want to do is to move into any random location, any location in a random direction, which is adjacent to the current tower location. So here now comes in the use of the random function, but before that, here now comes the use of the random function. I'll define the variable dir. if you remember, I had this defined earlier here, and this has all the directions. So I'm going to generate a random number between 0 and the length of all the directions to choose a random direction in which I want to move. So RNG, random number generator, which I defined earlier here. So RNG dot uh, next integer. Yeah. So this will choose a random direction. And now I want to define something called a map location, which is basically, yeah, like it's called, it's basically just a map location. And it's going to be named log. And I'll get the location from the robot controller. I'll get the location of the tower from the robot controller. And then now that I have this direction that I've chosen arbitrarily, I can add it to the current location to indicate the next location which we want to move. So I'll do that with the add function, which takes in one of the directions that I chose up there. So now we also have, I would find a robot type, which can be one of the three that I handle here, a soldier, a mopper, or a splasher. So once again, I will generate a random number between now, there's only three possibilities. So I'll generate a random number between 0 and 2 inclusive. And I'll ask, and based on what number is generated, I will choose a different behavior for every one of the robots. So run the generator, the next. The argument I put here is always the maximum exclusive. So when I put 3 there, it's going to generate from 0 to 2. So now I'm going to change my behavior based on the type of the robot. If we have, for example, if the number that we generated is 0, then I'm going to try to build a soldier. If the number is 1, I'm going to try to build a splasher. And if the number is 2, I'm going to try to build a mopper. So I'll do that right here. Robot controller. So I'll use the can build function to determine if I can build, in this first case, a soldier. So there's a constant defined called type the soldier, which is the type of this, the type of the player, the type of the robot, sorry. So this, if the number that's generated is 0, I'm going to check if you can build a soldier in the random function that I've chosen earlier. If it can, then you just build it. Remember once again that this is just my strategy and you can choose whatever strategy you think will work best. And this is probably a really dumb strategy. So you probably should do better than this. So you build, you can see again here that the robot controller basically has all the functionality that you need. So now I build the robot using the robot controller build robot, and then you pass in the type of the robot you want to build and the location in which you want to build it. Just for debugging purposes, I can then still use standard print. And now I'll implement other behaviors. If the number is 1, and we can build a splasher now in the next location. then we should just build the splasher. And then the final behavior. If the number generated is 2, we're going to build, you're going to check if you can build a mopper. If you can, we are going to build a mopper. And remember, we can build only because it's a tower. Like the robot controller now, I know it's a tower, so that's why we can build all of these things there. If you try to build using a robot controller that's not a tower, I would guess, I've not tried this, but I would guess it would throw a game action exception because it's illegal in the game. So the last section is going to be, we're going to define a variable robot info, which is, we are going to use the robot controller to sense any nearby robots. And if we sense anyone, we're going to attack them. Once again, it's just my strategy. So robot info, we create an array with where each array element is going to be any robot, any nearby robot that has been sensed. So to sense the robots, we use the sense nearby robots function in the robot controller. So now we say for each structure, for each robot in the nearby robots, which is an array of sensed nearby robots. For each one of them, if it's possible to attack the robot that we found, like the robot that we sensed nearby, if it's possible to attack it, then we just attack it. Robot controller dot attack. Robot dot get location. And yes. So this is the behavior that I've implemented for my tower. You can choose whatever behavior you want. The first thing is that if I can upgrade my tower, what I decided to do is that if I can upgrade my tower, I should always update it. And that's what this does. And then now we are going to try to build a robot based on some random number that we generate. So if you can build a robot in some random direction, then it's going to build the robot. And then that is what this part of the code does. If we can build a robot in some random adjacent direction, it's going to build a robot. And then the last part is if you can attack, then it should attack. So my part is done. I'm going to leave the floor to the other there, who's going to continue with the rest of the functions. Thank you so much. Please share the screen.
Okay. So
Yes.
let's just okay. So let's continue. Wait, there's an echo, it seems like. Okay. So that should be working now. Okay. So let's continue off of, give me a second. Let's continue off of where Leo just left off, which was we implemented the run function as well as the run tower method. So now let's go on and see how we can implement like specific behaviors for different types of robots. So as we defined earlier here, we looked at each robot and saw if it was a soldier, a mopper, or a splasher. So let's first implement maybe a method to like to decide what a soldier does. So let's just start off with like oh yeah. So let's do public static void. So we're going to define a run soldier method as it's going to follow the same format as before. So first thing we can do is from any given location, let's let the robot soldier sense any like nearby things that could be interesting. So we can make an array of nearby tiles. And we can call the sense nearby map infos method. And what we can do is with a soldier, maybe let's try to see if we can find any ruins, because if we can find a ruin, maybe we can paint some kind of pattern and then construct some towers, which can be useful in like winning the game. So let's first define our current ruin as null. So right now we haven't found any ruin yet. But now let's loop through all the tiles that in the nearby tiles. So for each tile, we're going to check if the tile has a ruin. Then we're going to set the current ruin to the tile. So that way, in doing so, we loop through all of the nearby tiles and see if any of those tiles are a ruin. And if it is, then we'll save that location. So now what we'll do is we'll say, so first, let's just make sure that we actually did find a ruin. So if the current ruin is not null, that means we indeed found something of interest. Then we're going to say, we're going to set the ruin as our target location. And we're going to do current ruin dot get map location to see where it is. And for now, let's suppose we want the robot to move in the direction of the ruin. So let's say we define a variable dir. So we have the robot's location, the soldier's location, and we can call the direction to method. Basically, it returns one of the 8 cardinal directions, north, south, east, west, or northeast, northwest, southeast, southwest, to determine what the optimal direction is to get to the location. And then we're going to say we want our robot to move, right? So we're going to say if the robot can move in the given direction, then we will move. And then, so now let's define another variable, another map location called like check marked, which essentially is like basically an arbitrary close by location to the ruin. So basically the point of this is like, we're going to, so with the robot, we're going to sense map info of check marked dot get marked. And if this is an empty paint type, right? That means we have not marked, we have not done any marking yet. And if we're allowed to mark, if we're allowed to mark the tower pattern, so rc.can mark tower pattern of, and we want to mark a pattern for the tower, so unit, we can do unit type dot level 1 paint tower at the target location, which is like at the ruin. Then we are going to mark the tower pattern. paint tower at the target location. So after this, we're going to look at all the squares that are like nearby, right? Because we have to paint a 5x5 like pattern around the ruin. So let's just say we're going to loop through for each map info for each tile. Let's just say pattern tile. For each pattern tile in sense nearby, map infos of target location 8. So the reason we use 8 is because remember in Battlecode we always use like the distance squared. So so in this case we're considering a distance squared of 8, which essentially means if you just visualize it, it's a distance of 2 root 2, which is like which represents the 5x5 square that we're interested in considering. So we're gonna for each pattern tile, we're going to check and see, we're gonna do pattern tile dot get mark. So we want to see if the mark is not equal to the paint that is on the tile right now. And we want to see, and we want to make sure that the tile is indeed marked. So we have done the marking as in the previous step. So pattern tile dot get paint dot get mark is not equal to paint type dot empty. So it's not empty paint type. Then we are going to see if we can like attack that like pattern tile. Attacking in this case is like painting. So if rc dot can attack pattern tile dot get map location and we want to see if, and we need to determine whether or not whether or not to use the primary or the secondary color. So we do if pattern tile dot get mark, if we need to use the secondary color, so allied secondary, then we're going to attack pattern tile, get map location of, and we're going to use the secondary color. Otherwise, we're going to use the primary color. And then, of course, we're going to at the end, we're going to check and see, can we complete the tower? Can we complete the tower pattern? So we can see if we can construct a new tower. So if rc dot can complete tower pattern of unit type dot level 1 paint tower target location. Then we're going to complete the tower pattern. Okay, so that's kind of the main logic with the ruins. The soldier is essentially going to try to search and see if there are any ruins it can complete. And then we use this logic to, mark the tower, mark the ruins and paint stuff and then construct the tower. And then otherwise, we also want to make sure, for example, let's see the robot doesn't see any ruins. We still want our robot to do stuff. So let's say we want to have a robot just move in a random direction and maybe just see if it can attack a given square. So let's say we have a direction variable. Again, as before, we're going to essentially choose a random direction. So we're going to do the same thing we did before. So this line chooses one of the 8 random directions. And then we're going to determine the next location by getting our current location. And we're going to add the direction that we chose. And we're going to see if we can move in that direction. Then we'll just move in that direction. And we're also going to check, can the robot attack at that location? Can it paint that tile? So let's see. So we have if rc.can attack next location. let's just make sure. And also, I guess, we also want to make sure that we don't want to, I guess, be wasting too much paint. Like if a tile is already painted, like there's no point in like, I don't know, you don't want to waste your resources. So we can do map info next location info equals rc.sense map info at next location. And if the next map location, the next location info dot get paint is not ally, so it's not one of our squares, then let's attack that location. So this is the general logic for the soldier. So we essentially, again, sense the nearby tiles, see if we can complete any of the ruins. And then if there are no ruins to complete, or at least within the vision radius, like we can just move in a direction and then try to attack and paint more squares. So that's for the run soldier method. So, and we also have, we can implement like a method for the mopper. So mopper robot controller. Let's see. So with the mopper, let's just do a pretty simple strategy. Again, let's just like choose a random direction out of the 8 cardinal directions. So, and then we're going to get the next location by doing rc.get location.add direction. So from here, what we can do is we can say, like similar to the soldier, if rc.can move in the given direction, then let's just move. And a thing about the mopper is it can perform mop swinging, right? So let's just see if, you know, the robot can do that. So we can do if rc.can mop swing in the given direction, then let's just do it. So rc.mop swing in the direction. And otherwise, if the mopper can attack at a location, then let's just attack that location. So that's the general idea for the mopper. It's pretty simple. We're just having the mopper move in some random direction. Of course, it would be, of course, like there are definitely many other ways to implement, like smarter ways, because right now it's just kind of moving in a random direction, seeing if it can perform like certain actions. But of course, you should try to see if there are smarter ways to do that. And then finally, let's like implement the function for splasher. So we're going to, again, just choose a random direction. And I guess it's kind of similar. We can kind of just take what we had before for now. And of course, the splasher doesn't have a mop swing method, so let's just remove that. And then, yeah, so that's the general idea for now. So we have the soldier method, which it looks at the nearby ruins and sees if it can complete any of them. And then it just moves in a random direction and attacks. And same with the mopper and the splasher. They essentially just, right now, they're moving in some of the directions and seeing if they can perform some attack. So this is like a pretty simple example of a bot that you can make. Of course, there are many places where you could like, I guess, like add things to make the bot stronger. But for now, we can like try running like we can try running our bot. And we can test it out and see what it looks like in the client. Seems like there is an error in line 152. Says incompatible types. Okay. So 152. Oh yeah, here, wait, we should be checking we shouldn't just be doing rc.attack. We're supposed to first check if we can attack, and then we attack. That same thing down here. So let's try running it again. Hopefully it should work now. This is just all of the random output stuff like we did before, like when we did the system.out.print line stuff, just to see what robots we've been spawning. So and then we can, I guess, in the Battlecode client, we can, I guess, like upload example bot, and I guess just, see how it's running. Like, got like a splasher here, like, I don't know. Seems like you have the soldiers, they're like, I don't know, they're painting tiles, and the splashers like doing stuff, I guess. And then oh wait, I guess the reason we don't see the splasher attacking that much is because I said else if, but should technically be if, because it can move and attack, doing both at the same time. But either way, like if you speed this up, like, basically see that we have a functional bot. Of course, for example, especially in like the soldier, the mopper, and the splasher methods, you can definitely like think about like more different strategies on how to paint the tiles or what to do with them or what direction to move in or stuff like that. But yeah, that's basically it for the bot in Java. This is a pretty simple bot. There's also like, I also quickly wrote like a Python version of the bot because this year we have both Java and Python. So just as a quick view of what the Python version would look like, it's basically the same thing, except we have the directions here. Every time we run, we have the turn function. So anything inside the turn function gets run. So we organize it so that we check what the type of the robot is. So if it's a tower, we're going to run the tower. If the robot's a soldier, we'll run the soldier, so on and so forth. And in the tower stuff, we do the exact same thing. We get the location. Let's see if we can upgrade the tower. Let's spawn some robots. Let's attack some robots. And then like the soldier method is also like, searching for ruins and then seeing if it can move and attack. Same for the mopper, checking if it can do its actions, and same for the splasher. So this is what the Python version of the bot would look like. But yeah, I think that's basically it. Those are like a high-level overview of like the different methods you can use, a lot of the different methods you can use, and how to use them. And yeah, I think that's it. So. Thank you guys for listening. Oh,
Resources top.
the Java docs. Okay, like this. Like, oh wait. So, yeah. Sure. Do you need? Let me see. Let me show a screen again. This? Yes. Oh yeah. So let me just go back to Battlecode. Yeah. So when you're on the Battlecode page here, you can go. So when you first go into Battlecode, this is what it looks like. So what you can do is you can go to resources, and then you can look at like the API specifications for Battlecode 2025. Basically, that has like a list of all the different methods you can call, like for the different soldiers and the towers and stuff. So for example, we can look at like map location or something, which is pretty important. You can see everything in map location. There's like a X coordinate and a Y coordinate. Here's a constructor summary. This is how you make a new map location. And then there's a bunch of methods like, add, it would just take a map location, it would add a direction to it and then return a new map location. And then you can look at other things like robot controller. That's pretty important. It has like a lot of very important methods that you will be very likely to use in your bot, whether it's for attacking or sensing or, stuff like that. So that's how you find all of the methods if you ever need to reference them.